Welcome to Spring Lib.
Here we have to calculate the force which is required to move a desk with a mass of 45 kilograms. If the friction between the desk and if the coefficient of friction between the desk and the floor is 0.45. So let's imagine the initial situation. So here is our desk, which feels the gravity, and we start applying the force, which is in the opposite direction with respect to the friction. And also, the desk pushes at the floor, and the floor pushes back at the desk with the force N. So in order to, when the desk starts to move, its acceleration is 0. So it doesn't have any acceleration, it moves with a constant speed. Therefore, we can write down the second Newton's law. So F plus force of friction plus N plus the gravity force equals to 0. So now we can introduce the coordinate axis and write down the second Newton law with respect to the projections on x and y axis. On the x-axis, the applied force equals to the absolute value of the applied force equals to the absolute value of the friction. And on the y, with respect to the y-axis, the reaction equals to gravity. And we also know that the force of friction equals to the friction coefficient multiplied by the reaction force, or friction coefficient multiplied by mass multiplied by the gravity. So now we can calculate the minimum force which is needed. So it equals to the friction coefficient multiplied by mass of the desk and multiplied by g, which is 0.45 multiplied by 45 kilograms multiplied by 10 meters per second square. So it equals to 202.5 newtons. So this is a minimum force which has to be applied to the desk to move it without any acceleration. Now let's answer the second question. So here, the mass of the desk is reduced by delta M, which is 17 kilograms. So therefore, the new mass of the desk equals to the initial mass minus 17 kilograms. So the system doesn't change, and that's why the force which is required to move the new desk equals to mu multiplied by the new mass and multiplied by g, or which is mu multiplied by initial mass minus change in the mass multiplied by g, which equals to 0.45 multiplied by, which equals to 0.45 multiplied by 45 minus 17 kilograms multiplied by 10 meters per second square, which is which equals to 126 newtons. So after 17 kilograms had been removed, the force needed to move the desk reduced to 126 newtons. Thank you very much. Bye.